have, well, Wazuh is, first of all, a platform, a security platform. And what we mean by that is that we have several capabilities built into one solution, right? It is a very holistic solution. And the architecture of it is that you have this single lightweight piece of software, which is called the Wazuh agent. Hi, Diego. I already started the recording and the demo. Okay. So we have this single lightweight piece of software.
Thank you. My connection just, don't worry, here I am.
I'll just power on through. Cool. So again, the Wazuh agent is a lightweight multi-platform solution that connects securely to the Wazuh analysis engine. And what it does is it monitors various different aspects of the security of your environment and sends all that information using a unique key for its encryption to the analysis engine. The analysis engine will use its different set of decoders, rules, and criteria built into it to determine the nature of each one of the events and what action to take from that. And one of the actions, of course, can be to log the event to determine, and it does then all the enrichment associated to that event. But it is also capable of telling the agent to take automatic actions against specific threats or specific events that may have happened. Then all of that logging gets integrated with the Elastic Stack. The Elastic Stack is basically a search engine that allows us to quickly browse through a lot of the information that is being produced by that analysis engine. And we also have an integration that's built for the Kibana server, which is a web interface, which is where I'm going to be showing most of the demonstration here. So if I go here over into the Elastic tab that I have here, you'll see this. And in here, we can log in either using a simple set of credentials like I've just done, but you can also bring in external authentication providers so that you have more convenience if you're already doing single sign-on with Active Directory or Google or any other solution. And we also have the capabilities of bringing in multi-factor authentication through that. Once we load this, we'll see that we have several different dashboards, and these dashboards focus on various aspects of the security of an environment, right? We have security events. Security events, it's going to be where everything is. Even if it doesn't have a specific dashboard dedicated to it, we will find all events over here. But then we have specific visualizations for file integrity monitoring, for example, cloud-based services, vulnerability detection is one of the key features I'll be covering shortly on. And then we also have specific dashboards for the various mappings that Wazuh does to the various events that are seen. So over here we have, for example, the MITRE ATT&CK framework is a great way to see the different events that are happening from the point of view of the tactics and techniques of an attacker, right? But we also have mapping on how each event relates to the various regulatory compliance standards like PCI DSS, HIPAA, GDPR, NIST 853, SOC 2. And this is something that you'll see throughout the solution, is that the solution is highly customizable, right? You can bring in your own rules. We do follow the openness philosophy very strongly and allow our users, we try to enable our users so that they can easily adapt the solution to fit their needs of their environments, since each environment tends to be quite different, right? So let's go ahead and see a little bit of the power of having this integration. So I mentioned the Wazuh analysis engine, when it receives all those events from the various agents or even from network devices or cloud-based services, it will add enrichment on how that event, for example, relates to the MITRE ATT&CK framework, but it also assigns to each one of the events a level of severity. This level of severity ranges from 0 to 15, and what it lets us know is how critical each event is to the security of the security of your environment. So, for example, level 3 would be all authorized events, anything that is expected to be happening on your system. And as it goes up, for example, level 4 might be errors or non-critical errors on the system. Level 5 might be user-generated errors. So what maybe when somebody provides a wrong password, that's going to be a level 5 event. And it's important that we keep those authorized events, for example, so that we have then the ability to go back and see what was happening in our system in the case of an incident, right? So, for example, we would be able to see who logged in around the time of a specific incident to just go do a very in-depth analysis. Then if we go over into level 10 would be, low relevance attacks or events of multiple user errors, like when somebody's trying to brute force their way in, just providing many different passwords. We'll see how Wazuh is capable of doing correlation of the most recent events based on the log analysis that it is doing. So let's say, for example, if I want to see anything that's level 12 or above, which is what's considered critical, I can just click there and you'll see that most of the graphs, or actually really all of the graphs, have the capability of simply clicking on them to generate filters, right? Maybe I'm interested here in seeing, hey, what's this MITRE attack framework? Just seeing that exploitation for client execution. We have 3 different events on that specific time range over the last 24 hours. And bear in mind these are real events that we're seeing on our environment, since these machines are just open to the internet. And here I can see, hey, yeah, apparently our integration with VirusTotal went ahead and detected that a file in our system, or a file reported by our system, is detected by many different engines, by many different antivirus engines. So maybe I want to focus in on that specifically, that second time that went around, just see what is going on around that specific time frame. Maybe I want to see then who logged in around that time. So I can just click there on authentication successes, and just temporarily disable the other filters so that I can focus on who was logged in around that time into our machines. So we see here 18 authentication events around that time. We could focus specifically on the one where we saw that event, or just see them all together, which is, the great thing is that this empowers the security analyst to be able to easily navigate through all of that information. And for example, if I go ahead and see here, you can see that we have an authentication successes in SSH around that time. If I unfurl it, I will be able to see, hey, this is somebody from Argentina who logged in. This is, of course, somebody from our team trying to showcase how all of this can happen. And that way we are allowed to, bring in all of the information that is being created by this. We could go the other way as well. We could actually see what were all the events, the most recent events that we're seeing. And in most cases, you will be able to see, for example, all the authentication failures that are happening in your system. So for example, over here, we have this authentication fail, the latest event. And one of the things that Wazuh does is since it's able to ingest information from log files, from Windows Event Channel, from network devices, and also cloud-based services, is that it is built so that it can easily read information from many different sources independent of their format, right? So in this case, if you have a JSON source, of course, that will be easy for it to identify the messages. Also from the Windows Event Channel, everything comes pre-organized. However, in the case of many logs, especially in Linux devices and network devices, you'll see that, well, we have simple plain text logs, which is a line that was written as the developer thought it was fit for that. That's where the decoders of Wazuh come in. So for example, for the secure shell daemon, it received this particular message in one of the authentication files of this machine. Immediately it identifies, well, that's coming from the secure shell daemon, right? So I'm going to use that decoder, and from there I'm going to be able to see what is the source user that we have over here. So that's been extracted over there, and also the source IP. That's going to be very useful for a security analyst. So we want to extract that and be able to do that. Since it sees the phrasing failed password 4, it knows that that's the way that the secure shell daemon says, well, somebody had an authentication failure, and then it goes ahead and does the mapping on how that relates to various compliance standards like HIPAA, GDPR. We have all of those here in the MITRE attack framework. We see that this is related to the brute force technique, right? Somebody might be trying to brute force their way into the system. Since we have that IP, you may notice that this simple line of text, this is all that we receive, does not have any information of where this is coming from aside from that IP. So we want to make this as humanly friendly as possible. So we take that IP and we do geo-IP enrichment. So this particular IP is associated with the city of Islamabad in Pakistan. So apparently, well, some device over there is trying to brute force their way into our environment. We can then filter for this specific IP if we wanted to see, what else has this particular user done to our environment. And if we click for that, let's give it a second there. We'll see how all the events, it goes from, in that particular time range I showed before of that half hour, it goes and just focuses on that specific IP, all the events from that IP. We can see in this case, we are getting only attacks to one specific machine around this time range. However, if this particular IP, which is, a real attacker, had gone into more than one machine, was attacking more than one machine, we would be able to see it right here. And you may also notice that we have those rule levels I mentioned before, and they're almost all 5 except for these 2. And these 2 are something that's quite nice to look into, because you may see, well, SSH multiple authentication failures, but the log is basically the same, right? It's just a failed password for root. Well, in this case, what's happening is Wazuh is able to look into the most recent events and identify the behaviors from them, right? In this case, the behavior that it's finding is it simply failed to log in more than 8 times in less than 2 minutes. So that's, obviously a little bit more suspicious that when somebody fails their password once. It also has many other built-in rules, like if, for example, after multiple authentication failures, somebody were to manage to guess the password and log in, then that would be a high-level alert, since, hey, maybe the brute force attack was successful. And also even more if after that an account is created. So all of these things will allow us to, automatically be able to provide analysis into the system, but at the same time, making sure that it is easy for an analyst to come in and just take over, supplement the machine, whatever the machine is doing. I'm going to go ahead and now, maybe this particular IP has been doing something else aside these 1,000 attacks in that particular half hour. So I'm just going to expand my time range over the last week and maybe see, hey, what I could expand it over the last year. It's just that this environment we've just recently recreated when the latest version came out. So we're going to see that, instead of 1,000 hits, this is going to, well, if they've attacked us at any other point, it's going to be increasing and will allow us to see, well, has this user done anything else aside from just doing authentication failures, right? In this case, we have 15,000 different hits for the last 7 days. It is quite distributed over one specific time range. So it might be a machine that just found out our IP. And we can see here, well, we have several types of alerts, and they are all distributed over in the Ubuntu machine alone. I can go ahead and create, filter just for authentication failures, but then I can just, what I actually want to do is exclude this result, see if there's anything else aside from that. And immediately we get, well, yes, there is one event. And hopefully that's not an event of somebody managing to do an authentication success. But what we see there is that in this case, well, they did an attack where they were probably probing our system and trying to determine what's happening, right? So in this case, hey, possible attack on the system. If we see this, it's a bad protocol version where they're apparently, well, just trying to HTTP into the server. That's probably just somebody, trying to gather information, doing reconnaissance on that machine. Luckily, no authentication successes on this particular IP. Of course, this is the type of thing that allows you to, well, gather all the information, have all the information so that you can do a proper report on the system. Many compliance standards require that you keep these logs for this same reason, so that you're able to get a good idea of what is normal in your environment, and then notice whenever anything is off, or also be able to narrow down what may have happened in the case of an incident analysis. If, for example, you're going for PCI DSS or any other similar compliance, we add in mapping on each one of these events. And so, for example, we could figure out, hey, show me only the events that have any relation to 10.2.5, which is a requirement to keep logs of all invalid access attempts into the system. So here we have that. And, in the case of an audit, we're also able to provide the specific time range that they may require of us to demonstrate that we are keeping those logs, right? It is a tool that is often, whoops, we're now in December. Let's see, that is used a lot for compliance, because it is, businesses do want to be able to do business, and this is what will allow them being able to obtain certain certifications. So here we have that, and also we try to provide as much information as possible. So over here we have a control section which let us know, well, what's that specifically? What does 10.2.5 mean? And what are the events that are shown related to that? Okay, so that's a little bit on log collection. So once it does log collection, as I mentioned, from many different sources, the way that it does, for example, log collection for cloud-based services is that it periodically runs a script to securely log into that service and pull logs from the various sub-services that they may provide. So of course you can install the Wazuh agent on a virtual machine, but sometimes you get even more information from outside of those virtual machines that you may run on a cloud-based service. And that's where we come in, and we, with this model that can be adapted to other cloud-based services, and that we have out of the box provided for AWS, Google Cloud Platform, Microsoft Azure, as well as Microsoft Office 365, we were able to bring in the additional information. So here, for example, VPC of Amazon will let us know all of the activity that is happening on the network interfaces of our solution, right? And it does provide many other services that will give us information, for example, of who is accessing the different resources of our system, who is trying to attack us, as seen from the services, the security services provided by Amazon itself. So for example, VPC here, letting us know all of the activity and the different network interfaces that we have there. If I filter out that service, which is quite noisy, we will be able to see, for example, all of the activity coming in from AWS CloudTrail, and they're seeing all those accesses. Let's see. Sorry for that. Oh, and actually here we have a little bit, the most recent activity, or the at the end of that day, which I was looking at before, is from Guard Duty, letting us know that, hey, somebody made an API call using root credentials. That's obviously a bad idea. So it's something that you should be noting. It does have many other services, including services that will let you know if there is any risk of data exfiltration on your cloud-based services, which is great, because you may want to see what are the best ways to configure things. Then the Wazuh agent has several different capabilities. One of the key components will be file integrity monitoring, which will, or integrity monitoring really, since it not only works on files and folders, but also on the Windows registry keys, right? And what this does is it lets us monitor critical folders of the system and critical registry keys for any modifications, and keep track of those modifications and keep as much information as possible from them, so that we will be able to determine if somebody, for example, tries to modify a binary to sneak in a backdoor, or if somebody changes the configuration of a critical file in the system. The way that it does that is that by default, it will monitor the operating system's most commonly critical files and folders. But you can set it to monitor any specific folder, and it can be done either on a scheduled basis or a real-time basis, where it monitors any change occurring on that folder. And it also has the capability of letting you know who made the different changes and what was modified inside of the file. Let's do a quick demo. This works on Windows as well as Linux and Mac OS, but I prefer showing it in Linux since it's a lot more text-based, so it's a lot simpler. What I normally go ahead and create here, let's go ahead and create a file that says hello. I did that as the user Wazuh that I just logged in and asked. And if I elevate my privileges now to root and modify that file, you will see how all of that is seen on the system, right? If I go ahead and delete that file, all of these different actions will be taken into account. If I go ahead, let's go ahead and jump into the last 15 minutes. you'll see that you have that very powerful selector, and you can set it to automatically refresh as well. Here we have a very simplified graph that in the last 15 minutes, well, we've seen one action to add a file and then another one to delete and then modify the file. If we go into the events section, and that's something that we did before, Wazuh always allows you to see all of the details of each one of the events that you've seen in the past. So for example, here, if I unfurl this one for the modified one, we can see that that file has this full log that we can go through, but we can also focus on the specific fields of it and see, well, that was modified by root. This is associated to the MITRE technique of stored data manipulation, and a lot of other mappings there. But it also lets me know, hey, yeah, even though that was done by root, that root user originally logged in as Wazuh. So just in case, you know, they're trying to obfuscate their identity by elevating privileges there, you get that login username information. Also, what was the process that made the change? What process opened up that process? Again, allows you to have a little bit of visibility of what is the chain of events that happened. And then, for example, over here, we have what was modified inside of the file, right? What I did there with BI was change, well, the word hello to the word bye. It also keeps track of many different attributes of the files, including creation time, modification time, ownership information, permissions information. In the case of Windows, it uses the Windows ACLs to let you know what what are the different permissions on the file. And it also calculates the hash of the file using 3 different algorithms: MD5, SHA-1, and SHA-256. SHA-256 is, at least until now, it is not falsifiable, or at least nobody has proved it to be falsifiable. SHA-1, even though it's falsifiable, it does require a lot of computer power, but we do keep it here as well as MD5 for a very important reason, and that is that there is a lot of information out there that we can use to identify different types of files, right? There is a lot of threat intelligence information associated to the different hashes of the files. So for example, if I go ahead now and, let's go ahead and into a root folder and download a virus. In this case, I'm going to download the ACAR test file. You can see that it's there, but if you look again, aha, it's gone. And it is gone because 3 different things happened in quick succession. So first of all, this file integrity monitoring event, well, it detected that there was a new file. It also detected, hey, what's the hash of that file? And since we have that bit of information, we can use Wazuh's integrator daemon to query an external database. And it could be a local database, but in this case, what I'm doing is querying VirusTotal. That VirusTotal alert you saw before is basically Wazuh automatically, when it sees a new file, going ahead and asking VirusTotal if that hash is known to be associated with anything malicious, right? And in this case, well, it came back saying, yeah, 57 engines detected that this file was malicious. And you can see in the alert, we have all the information well organized of, it queried 64 different databases. Almost all of them had this, and it was considered malicious according to VirusTotal. You can go ahead and visit the URL of VirusTotal for this particular request and see, hey, look at this. This is all of the antivirus engines that consider this file to be a bad one. And since we had that response, then the third element of Wazuh kicked in here for this event, and it was an active response. Active responses are what we've named our EDR component. And what this does is, in response to a specific event, it will take action on the endpoints. Notice that this is on one of my agents, not on the analysis engine. And what it does then is it allows you to configure it to automatically delete specific files using that response. Okay, and this type of active response can be used for many other things. So, for example, you can use it to go ahead and block an IP that is attacking you, or disable an account that may have been compromised or may be on the verge of being compromised. You can also isolate an endpoint or just shut it down if there is any indicator of compromise. But it can also be used for many other things. I've seen it being used for automatically creating and or restoring backups from a system following a specific set of criteria when you see different events on the system. And again, this is highly customizable. You can set it to run on specific rules that you've created, or to run on any specific type of criteria that is already built into the solution, right? And actually, that's something I wanted to touch on. If we go here into the rules, we'll see that Wazuh has out of the box more than 3,000 different rules to be able to identify logs from many different sources, right? Over here, you'll find, well, on your typical antivirus system. So if I look, for example, for Norton, it's not what I normally, that's not the name, sorry. But the yeah, if I simply look for antivirus, I can see, probably see ClamID, Panda ID, Windows Defender, of course, is brought into this. Oh, there we go, Symantec there. But one of the great powers of Wazuh is that it allows you to both modify the existing rules, create sub rules to existing rules, and just create altogether new rules. So if we go here into the custom rules, you'll see that in this environment, well, we've created 200 different rules to be able to identify events from different sources. And one of them, for example, was to, whenever we see an event on a specific folder, go ahead and say, hey, somebody added a file to that specific folder, right? And create a specific response against it, so that you're able to take better actions and also help your security analysts to better address any issues. You may notice, well, this is an XML file. It is not necessarily the most user-friendly thing at first sight, but it does work so that once you get acquainted with it, it is a very much copy and paste operation, right? So for example, if I wanted to modify one of the rules that I'm already seeing, it has this example over here that I'm seeing, authentication failures. That's rule 5716. Each one of the rules has its own identifier, but you can also use groups or levels to identify them. And if it's coming, if we see that event, but the event is coming from this particular IP, so somebody at Cloudflare is trying to log into our system, then we can create a very high level alert or modify how the alerts work. And if I wanted to create a different one, I can create one just by copying and pasting it, giving a different ID, and just maybe giving it a different IP to work with, right? It is as simple as that. Once we hit save, that allows us to take that into effect and work with that new rule into our system. It allows you not only to use specific matching values like this, you can also use regular expressions, or you can even use lists, full lists of IPs or hashes or any other criteria that makes sense for you to identify the various types of events happening in your system. So for example, over here, we're bringing in the Open Threat Exchange reputation database into our system, which includes thousands, actually hundreds of thousands of different IPs that let us know who is, and normally it's already been identified as an attacker by other people. You can bring it in all into one, into Wazuh solution very easily, thanks to how it is highly customizable. Okay, so I did diverge there from the capabilities. Let's go back a little bit into the capabilities, and I'll delete that so that it's not causing problems for the other people demoing. So another very popular capability of Wazuh, one that gets a lot of attention and that has been improved greatly in the recent years, is the vulnerability detection. And the way that Wazuh does vulnerability detection is at an application level. What I mean is, well, you have the Wazuh agent, and it has it collects information on what applications are installed on the system, what are their versions, and what patches and updates are present on the environment. All of this gets sent, as with the other events, to the Wazuh manager, where it also keeps an updated database of the vulnerabilities that are being published constantly. So it collects information from the National Vulnerability Database, as well from vendor-specific feeds from Microsoft, Canonical, Red Hat, and Debian to know which vulnerabilities have been published and which patches mitigate those vulnerabilities. The end result is that it lets you know what packages are exploitable in your system, and it gives you a lot of information on how they're exploitable and what you can do to mitigate those vulnerabilities. If we look here, we have a sort of same dashboard view where we have, well, what are the most affected agents? What are the CVEs that are most present in our environment? What are the packages or applications or libraries that are most affected? And we can focus, for example, only on the critical alerts to begin with, right? It facilitates, organizing the work as much as possible. We can see that the one that has the most critical alerts, in this case, it's an outdated Mozilla Firefox. And this, I think, greatly illustrates the benefit of doing vulnerability detection at an application level, because this way we have the capability of seeing vulnerabilities that require user interaction to be exploited, right? Many vulnerability scanners out there will try to break into the system, try to exploit and let you know what they can exploit automatically. But doing it at an application level also lets you know vulnerabilities that could happen when a user clicks on a phishing links or simply just sees a malicious ad on their browser that might get to them to get a takeover of their environment. And in having this information as soon as the vulnerabilities get published gives you the advantage on knowing what you need to patch and when you should patch it to reduce the attack surface of your environment. One of the exercises I've loved doing is, since this is constantly updating, I know I have many very outdated vulnerabilities on this environment because it's a demo environment, but the vulnerabilities get published at a rate of about 50 every day lately. I mean, last year, more than 18,000 vulnerabilities were published. And so being able to automatically download this database every hour and be able to identify whenever there is a new vulnerability will give you the advantage over those attackers that once they see these vulnerabilities published, they try to add them to their own arsenal of or tools of attack, right? So for example, if I go ahead and see, well, what are the vulnerabilities that have been published over the last week or so? Let's go ahead and say 11 and 23 or so. In between that and now, we will see that, well, we don't have any critical ones, but we will always have new vulnerabilities being published. So we're here, we see that the kernel, Linux kernel of my Red Hat machine and my CentOS machine do need, have newly published vulnerabilities, as well as these Python performance library tools there. And it's great because, I always get hits when I search for these recently. It is something that provides a lot of value just from the start of the system. It continues to provide value since it is a very active subfield in the cybersecurity landscape. Very related to vulnerability detection is the security configuration assessment module. And this, the SCA module, what it aims to do is to constantly monitor all of your different endpoints to see if they are following industry standard benchmarks on how things should be configured, right? You may have everything up to date, may have all the patches installed, but that does not save you from having a bad configuration, from having a large attack surface due to a bad configuration. So what we've done here is we've brought in many different benchmarks, many of them from the Center for Internet Security, and we adapted into this module that runs automatically from the Wazuh agent, allows you to see, well, are the files, the configuration files done correctly? So here it's telling me, well, I'm doing 37 things correctly, 18 of them could be improved. I can click on that to only see those that are failed. And in here we can see various different suggestions on how to improve the security of my system. So for example, ensuring that the interactive logon does not display the last user should be set to enabled. So if maybe I don't understand why that's important, I can click on that and see, well, here's an explanation. An attacker with that, well, you're giving them the name of a valid account, so they only have to guess the password after that. So good, it's a good idea not to show that. How to fix it? Well, you just need to modify this particular Windows registry key and you're all set. And that's actually, well, it's also letting us know that that is actually what it looked for when it determined that we were failing to do this correctly. It also adds information wherever we can. We add information on how it relates to compliance standards. So apparently, for example, this is related to PCI DSS 2.2.4, sorry, 3.223. And yeah, if I wanted to share this with somebody, all these 18 different checks, actually, I'm just showing there the first 10, all these 18 different checks with somebody, I can click here to just export this as a table and share it with whoever might be, in charge of ensuring the hardening of our environment. And that's something I didn't show through all the different dashboards. You have the capability of creating a report, a PDF report with all of the filters of the specific view that you have on your screen, right? If I go ahead and create this filter, I've set it to only look at my Windows machine over the last 6 hours. It will generate a PDF report that I can share with whoever wants it. So just, after it's done, success, go to Wazuh Management Reporting. We will be able to see that information over here. Again, we can also generate our own reports, our own visualization dashboards. We are able to see, well, what are the different events that have generated these particular graphs. Over here, we see that most of them for this Windows system is that there is a signed script proxy execution event constantly happening there. So that's probably something worth looking into. Yeah, and Wazuh does integrate, as I shown, with many different log sources. Of course, we don't have specific dashboards for each one of them, as it doesn't make sense, but you can create your own. But for example, we have also integrations with the Docker servers, in which we can keep track of what are the different activities that are being created on Docker containers, right? If Docker containers are being created, run, deleted, pulled, all of that activity. We also integrate with OS Query, with Sysmon, and many other different tools that allow us to easily see information. And one of the great things is that you can create very easily integrations with other pieces of tool, right? When we saw that integration with VirusTotal, where we took information of an event, that new file detected event, and sent it over into this external API, we can do that for many other things. And we have created, for example, a similar integration to send out alerts via Slack or Telegram, if you're using Telegram, or Microsoft Teams, anything with an API, or also bring in an incident management tool. So you can bring in, for example, Jira or PagerDuty and send information out into that. And I know for a fact that many people in our community have also brought in orchestration tools like the Hive, for example, is one that is most used by our community to integrate Wazuh so that we can, orchestrate different actions to be taken when different types of events occur. This interface, aside from allowing us to visualize all of this, it also allows us to easily modify the configuration of both the analysis engine when we were creating those rules, for example, but also what we want to monitor in the different endpoints. And that I've gone here into the groups section, because here we can add agents, each one of our endpoints, and we can do so when we install them automatically to different groups. Each agent can be part of several groups. For example, here I have my Red Hat. We can see that my Red Hat machine is part of the Red Hat group, but that same machine is also part of the Apache group, because we have an Apache web server on them. And for example, in that we have configured it, we've pushed centrally the configuration to monitor the configuration files of the Apache web server. So here we're seeing, letting me know anytime somebody changes anything in the conf files of that Apache web server, it lets me know what has been modified, but it also lets me know, well, what is being put into the error log and the access log of that group. And you can, use this to organize your environment the best way possible, so that you can easily know what you are monitoring and modify it centrally. It scales very well for many different endpoints, and we are constantly seeing both people who use our support are using, well, this for hundreds of thousands of agents in the most extreme cases. but it scales well starting from a few agents there.